This is the intro video for Algebra 1, section 3.4. We're going to be looking at slope in this video. So we're going to start off by defining slope. The word slope, slope of a line, is a ratio that compares the rise to the run. Rise to the run. So rise is a change in height. And run is I'll call it a horizontal change. And so what we're going to do is we're going to use this definition of slope to help us figure out what the slope is of this line that we see graphed below. So I'm going to look real carefully at this line. You can see that from left to right it's going uphill. That's an important thing to notice. But what I'm going to do is on the graph itself, I'm going to try to locate a couple of points, two to be specific, that I can clearly see are on the line. So I see maybe this point right here is on the line, and I don't know, maybe this one right here. Those 2 points appear to be on the line, and so I can use those. There are others that I could have used, but I chose to use those. So between those 2 points, what I'm going to do is I'm going to try to figure out what the rise and the run would be. So I'm going to draw in a little vertical mark right there, representing that vertical change. That's going to be my rise right there. And then in red is going to be my run right there. And then to figure out what the rise and the run would be, I'm going to just count some squares. So for the rise, if I count those squares, it looks like I've got 2. So my slope will be a rise of 2 over, and then the run, I will again count those little boxes as I go across the run there. I'm seeing 1, 2, 3, 4. So the run would be 4. And so putting this together, we reduce the 2 fourths, we end up with 1/2. So the slope would be 1/2. One thing to notice here is that slope of 1/2 is positive, and that actually goes pretty well with what we see on the graph. The general idea would be if a line is going uphill from left to right, then its slope should be positive. If a line happens to be going downhill from left to right, the slope will be negative. We'll look at those later. For now, that's a definition of slope. Next, we are going to take a look at the formula for slope, which is right down here. So we do use the letter M frequently to refer to slope. So that's what I've got going on right there. And then the formula for slope between any 2 points, just like we did a moment ago, is right here. It's y2 minus y1 over x2 minus x1. And I want to try to connect this with what we just talked about. Y2 minus y1, that would be the rise. And x2 minus x1, that would be the run. And hopefully that makes sense because, well, you can make this connection that the y's do have to do with how high or how far some line would rise. The x's have to do with how far the line would run. So this is, other times you might see this written like this, delta y over delta x, and those deltas are supposed to be little triangles. The delta is a Greek letter, which means the change in. So the change in y over the change in x. All right, so we're going to use this formula now to find the slope of the line defined by a couple of points. So what I would do is write m equals, actually before I do that, I'm going to identify which point I want to be my point number 2 and which one to be my point number 1. I usually keep that really simple. I'll just call this point number 1 because it comes first, this one point number 2 because it comes second. It doesn't really matter which one you pick to be number 1 or 2. You just got to be consistent with whatever you do pick. All right, so I'm going to write m equals, so since these are x and y coordinates, both of them, I'm going to be able to pick out my y2 and my x2 and so on and so forth. So I'll highlight these for us. y2 would be -4 because it's the second y. So I'll put -4 minus, and then y1 would be the 5 because it's the first y. So I'll put -4 minus 5. In the denominator, I'm going to be looking at my x's. So x2 would be right here. That's because it's the second x. So 2 minus And this final step is a little tricky for some folks. It's always going to be x2 minus x1 and y2 minus y1. So when I get to this, my x1 is a negative number, so it's going to be 2 minus negative 3. There's two negatives in there for two different reasons, but there are two negatives, and so we would say minus a negative is really plus a positive. The numerator ends up being negative 9, the denominator ends up being 5, and so negative 9/5 is our slope. That would mean that this line, if graphed, would go downhill from left to right. Finally, we're going to look at a brief application of slope. We'll only focus on one in our class, and that is the idea of rates of change. Rate of change is always going to be a slope concept, and so we're going to try to use that concept within our question here. It says an investment company advertises a stock that is selling for $22.50 per share. 6 months later, that same stock is selling for $27.83 per share. Find the average rate of change of the stock's price in dollars per month. So keeping in mind that rate of change, or average rate of change here, is the idea of slope between 2 points. So I'm going to say rate of change equals, and you could say, you know, from the formula we did just earlier here, y2 minus y1 over x2 minus x1, but there aren't really any y's or x's in here. There's only dollars and cents and months and things like that. So we're going to have to adapt this a little bit. I do want to give you a little bit of a hint. Whenever we're looking at rates of change, pretty much all the time, I can think of almost no exceptions to this, the time is going to be in the denominator. So I'm going to go ahead and put delta t down there, standing for the change in time. In the numerator, since we want this rate of change to be in dollars per month, in the numerator I'm going to put in dollars. So I'm going to say delta d for dollars over delta t, t standing for time. All right, so the change in dollars would be the second value minus the first value. So originally the stock was selling for $22.50. 6 months later, the same stock is selling for $27.83. So that tells me that $27.83, that is the second price of the stock, like it's the one that's into the future. So that's going to be my Y2, or my D2 in this case, so $27.83, minus my D1 would be my original price, minus $22.50. All I'm really finding is the change in the price of the stock, or the change in the dollar value of the stock. And then the change in time, of course, is right here. It is 6 months, so I'll just put a 6 right there. You could say 6 minus 0, but of course that's just 6. At this point, it would be time to, time to use the calculator, so let's do that. When we do the subtraction in the numerator, we get $5.33, still dividing by 6, and when we do that division by 6, I'll round, since this is dollars and cents, I'm going to round this off to the hundredths place. So this would be 0.89 dollars per month. That would be the rate of change. So you could say that it's, on average, the price is going up 89 cents per month if you wanted to. This does say in dollars per month, and so that's why I use these units of dollars. Hope that worked for you. I'll see you in class.